All right, well, good morning, afternoon, or evening, depending on where you may be. Thank you for standing by and welcome to today's Tivoli User Community Webcast. Our topic for today is Hacking Workload Scheduler, Security Exploits You Want to Avoid. All phone lines are currently in a listen-only mode, and later there will be a question and answer session with further instructions being given at that time. You may ask a question at any time during the presentation using the chat window located in the control panel. Questions will be answered at the end of the presentation with the rest of the Q&A. Today's session is being recorded, and you'll be provided a copy of today's materials following the call. Now I'd like to introduce our speakers for today. John Ellery, Vice President of Automatic IT Corporation, has been working with IBM Workload Automation Solutions and the former Maestro for many years. John has helped numerous clients integrate IBM Workload automation products into their business environments and has written several agents integrating workload automation with various platforms, infrastructures, and business-critical applications. And Jonathan Conley is an application administrator at Boston College in Chestnut Hill, Massachusetts, managing IBM Workload Scheduler and Microsoft Active Directory administration. In addition, Jonathan is an adjunct faculty in the Department of Philosophy at Boston College, where he is currently completing his PhD dissertation work in the area of philosophy of technology. John and Jonathan, go ahead and take it away.
Thanks for joining us. I'm just going to go through the agenda quickly. This is at Jonathan Conley. It's two Johns today. So our agenda for today's meeting is we're going to go through an overview of potential threats to the workload scheduler environment. So ask the questions, why is security such a critical component of workload automation? What are the potential threats, technical, personnel, administrative processes? We talk about network intrusions. What types of network intrusions are there? What are ways to mitigate those risks? We'll see how do we know what users are the users they claim to be. We'll talk about identity management, specifically LDAP and Active Directory integration and single sign-on with the dynamic workload console, enforcing boundaries of users' roles, implementing a least privilege security model, who needs access to what. I'll talk about the TDO security file. How do we secure agents, specifically kind of SSL agent communications issues, protecting against physical intrusions, how to mitigate those risks, and finally, who did what and why auditing. It's a really important component as well. And we'll follow up with a summary. It's kind of the security hardening we can do to mitigate the risk to the environment as a whole. I'll turn it over to John Ellery.
Okay, thank you. And thanks again for joining. We're going to start out just by talking about a little bit about the workload automation security and why it's so critical. If you think about where you're installing agents, they're basically on a lot of your servers and in your critical infrastructure. And those agents will have basically administrator level access. Now, we'll talk about some configuration changes you can make to limit that access by those agents, but in general, they have full access to the system. So if you have access to the workload management environment, you have pretty much administrator level everywhere. So we have to make sure we understand that and control that. Also, the title says hacking TBS. We're really not focusing on hacking environments. What we really want to point out is what features are available to you and what functions are available within IBM Workload Scheduler to support locking down your environment where necessary. The next thing we talk about is workload automation really does touch a lot of different systems. So the critical business processes, you've got a lot of sensitive data potentially on those systems, and you want to make sure that workload automation doesn't provide a way that somebody could access that when they shouldn't. We have components that could be inside your corporate network. They could be in DMZs. They could be at client sites, vendor sites. You've got cloud implementations, right, of TBS, the IBM Service Engage. So you want to make sure that all the security components are configured in such a way that you protect yourself in those environments where you have agents distributed around. The other thing is we've got a potential for not necessarily using TBS or IBM Workload Scheduler to hack directly, but be able to insert things in your environment that could hack the application. So it could be a vector for further attacks. Right? So those are all things to consider if you're looking at security. And just talking about some of the attacks, you've got man-in-the-middle attacks where somebody's inserting a system between some agents and you're not aware that they're actually collecting data or changing data in that situation. Compromised key attacks. This is a pretty important one to remember with TWS because the keys, SSL certificates, basically key and trust stores, the passwords are all published in the documentation. So, and it's the same key, especially on the TWS side, the same key in trust, same certificates, I'm sorry, for server and client on everybody's system, right? So that's something to be aware of. Got password-based attacks. It's very common to find in customer environments where very simple passwords. You know, you see a Maestro password, a Tivoli password, maybe with a 0 or a 1 somewhere in there, but very, very common to see very weak passwords for administrator accounts. Again, if you've got access to TBS, you've got access to your environment. So, and you want to make sure you have a robust password. There's IP spoofing where computers can pretend there's another computer, possibly. We've got eavesdropping where you could be trying to listen on the network to look for what's going on between agents and things. So other possible threats could be disgruntled employees, somebody that's you know, basically looking to harm your business or harm your systems. More commonly, though, disgruntled is probably not the most common case. More commonly, it's just imprudent actions or inexperienced or uninformed people that really not sure what they're doing and make a mistake in the environment. And again, security can help protect against that too by making sure that people are locked down to just their role and they can't have more access than they need to the system. And then another one that's important and not necessarily thought of all the time is unpatched or out-of-support components. There's security updates and patches all the time being released for various applications, libraries and things. So if you're running an older version, you're more susceptible to things that have already been exposed as security risks. So you want to make sure you keep your workload schedule and environment as up to date as possible. As far as intrusions concerned, most IBM workload schedule environments that we encounter are inside a corporate network. So there's fairly low risk to an outside hacker coming in and getting access to TBS. You've got firewalls, DMZs, and even intrusion detection tools that are going to be monitoring for intrusions or potential intrusions. So I don't want to overly alert or concern anyone, I guess, in terms of the default configuration. If you're inside a corporate network, you probably don't have to do a lot of the configuration things we're talking about here. Just want to make you aware that they are there in case you feel there's an elevated risk in your situation. So you can use SSL. That's the default configuration for many components. I've got some slides in here that go into a lot of detail on that. We're not going to go over all those today, but they will kind of give you some feel for, or give you a feel for what components talk with SSL and which ones don't. If SSL is not good enough, there's the Federal Information Processing Standard can be used. There's information in the administration guide on how to configure your system to use that if that's a requirement for your business or organization. So that's a higher level of security encryption standard. This slide just shows the different components that use secure connection or not by default. All right, so as I mentioned before, the SSL certificates delivered with TWS, they're the same in all installations for the server and client keys. I think I lost my connection.
Yeah, John, I think your audio might be cutting out a little bit.
Okay, sorry. See if I can get a little closer to the mic here. So can you see my screen again? Is that my screen back?
Yep.
Okay, good. All right, so the server and client keys for TWS are the same in all installations. You could use either the iKeyman utility, or you can use the Websphere Administrative Console to open up the key and trust stores. You can see the actual key values and the expiration dates and key signatures, basically. So, and again, the passwords for those key stores and trust stores are all published, so anybody can basically find out what keys you're using for SSL. So while it is encrypted, the communication, unless you're replacing those keys in your environment with your own keys, so the self-signed keys that are delivered, it's not as secure as it would be with your own keys. The DWC server and client keys are also, those are actually unique to your environment. They're generated during installation time. The DWC server root key is expires, I think, like 2030 or 2032. I think it depends on when you install, basically, in that case. But the actual key that's presented to your browser expires once a year, and then it will automatically refresh about 30 days prior to the expiration. So you get a new key up until the 2032 date or 2030 date. I forget the exact date. In any case, that you will regenerate. You will still get a browser warning in that case because it sees it as a self-signed certificate, and it's not trusted. Your trust store for your browser will not recognize that root certificate. So you can actually import that into your trust store, your browser's trust store, and usually eliminate those warning messages. There's a number of ways you can go about doing that. But all right, so this just tells you the location of all the different key stores and trust stores. If you want to actually replace the default keys, the documentation, the administrator's guide contains information, the planning using guide also has information you can use to update the actual keys. All right, so FTA communications, you don't really use any kind of SSL to begin with. You can use SSL, or you can use the FIPS standard if you want to for increased encryption. The default is open SSL, but you can switch to FIPS. If SSL is a requirement, then you want to make sure you replace your certificates to make sure that you have keys that no one else knows the passwords to the stores, and the keys are unique to your environment. So this is just more detail about the FIPS standard. If you have to use that again, I would go to the documentation. It's a fairly detailed procedure on how to update your environment to use that. You have to switch libraries instead of OpenSSL. You have to use GSKit. And all components of that environment must be configured for FIPS compliance in order for it to operate properly. That includes the DB2. I think it's a requirement to actually use DB2 in that case too. All right. This just goes through some of the configuration changes you make to change, like the event processor to use secure communication, the TDWB, the Dynamic Workload Broker, CLI, for configuring that for secure communications, and then using the FIPS for DB2 connections. All right, so that's pretty much the network intrusion side of things, protecting your network. Like, just kind of in summary, there are many components using SSL today. It does use basically a common key for everyone for the TWS server and client keys. So if you want to lock down your environment, I would plan on generating your own keys and updating your environment to use those keys instead of the default keys. John, I guess we'll transition to you.
Yeah. So in the following slides, I'm going to talk about the TWS and DWC authentication and authorization. So authentication being verifying users where they claim to be, and then authorization verifying users have access to only the resources that they need to have access to. So kind of a least privilege model. For authentication, kind of a best practice or a recommendation is to probably use an identity management system you already have in your organization. So Identity management systems ensure that only authenticated and authorized users have access to certain network resources. Some of the advantages of using identity management system, provisioning and deprovisioning of accounts and account management. So not manually creating accounts and trying to keep up with passwords, synchronizing those passwords across different parts of your organization, single sign-on, federation, so being able to distribute access to multiple systems in different organizations securely, and different reporting and different kind of administrative tasks. The authentication types available for TWS and the DWC are Websphere Identity Management, or WIM, and so it provides basic identity, profile, and user information. These accounts have to be manually configured within Websphere, and they do not contain any password expiration. So again, a very manual process, and if you've been in the Websphere Administrative Console, it's quite complicated, especially for newbies, like I was myself. Local accounts on the OS can be used for authentication. Some disadvantages, you have to manually provision these accounts. It's hard to keep consistency across servers. There's kind of limited password policy enforcement and auditing. And kind of administrative issues you can run in, removing accounts, adding accounts. You want to make sure when someone leaves that those accounts no longer have access to your environment. The main environment I'm going to be talking about is LDAP, specifically Microsoft Active Directory. So we have some automated provisioning, deprovisioning of accounts and access. So new hires and when people leave your organization, kind of just only increases security, but also reduces kind of administrative overhead for you. Another component of authentication with LDAP is single sign-on. So single sign-on for the Dynamic Workload Console and TWS involves sharing a LTPA key, which is just an authentication technology that being developed so you can access different servers securely. So the high-level kind of overview of the process of implementing Active Directory and single sign-on are to basically we want to share the LTPA keys between Websphere and TWS, and then the Websphere environment in the DWC. So something to be aware of is that the LTPA keys automatically generate. So we need to go into both the our masters, backup masters, and DWC and disable the automatic key generation. If not, these keys will go out of sync and there won't be communication. We'll lose our single sign-on. So the process basically involves us exporting the keys from our master and importing them in the Websphere Administrative Console to our Dynamic Workload Console. After we do this, we have to restart Websphere. And then configuring LDAP. So most of our environments already have some kind of identity management system, whether it's Active Directory or some other LDAP system. We need to set up an account in LDAP to be able to access all the user and group objects that we want to use for authentication. So there's some steps and presentations that go through all the specifics, which I won't go through in this presentation. But be aware that you need probably to work actively with, if you have Active Directory with your Microsoft group, that create a security service account and then create the repositories. So you'll need some information from those groups to configure this in Websphere. Okay, in the next slide. So some considerations about SSL encryption and LDAP. If you are enabling LDAP in your environments, when you enable secure LDAP, it's going to require you to export keys from your LDAP or Active Directory environment and import them into the TWS and DWC trust stores. There's an option where you can connect directly to your LDAP environment, and it's called a retrieve from port. And it'll kind of pull in the keys for you. But be aware that there's some additional steps required if you're doing secure LDAP. Another kind of security precaution when dealing with these kinds of accounts is in the TWS and user ops files. So when you connect to a TWS environment with your own ID, it creates a .tws directory and user ops file. These are located in your user home directory. And the user ops file contains user credentials, username and password. Although the password is encrypted, these can be shared, so it's possible for these to be copied out of your directory if someone has access and used to access the command line interface. So it's important to kind of secure those. And also be aware any password changes that you make on your local machine are going to require that you manually update the password in the user ops file as well. So there's kind of some administrative overhead to be aware. Some repercussions, and you could be putting in the wrong password and be locking out your LDAP account or something. So again, some security considerations to be aware when you're enabling secure LDAP, and also about the user ops file. Okay, next slide. So we get to the authorization. So we talked about authentication, LDAP, some advantages of using LDAP, some identity management system. On the other hand, we have authorization. So verifying users have access to only the required resources. There's different ways and different access control rules and roles we can use. Within the DWC, you can create local users and provide them access through the Dashboard Application Services Hub console. We can create users in WIM again that we talked about earlier and assign roles to them as well. The recommendation is that we use some kind of LDAP and assign these roles from Active Directory security groups to restrict who has ability to add, modify specific and view specific kinds of objects. This enables us also to have less kind of administrative overhead when somebody leaves an organization if they are removed from that organization's LDAP environment. It's going to automatically remove them from accessing our DWC and also any of those roles that are assigned through our next step, which will be the TWS security file. So we can move on to the next slide. We'll get into more detail about how we actually restrict access roles. So the TWS has a authorization mechanism called the TWS security file. So the security file is able to restrict or enable users and groups to access particular objects in the plan and database. The TWS security file is very powerful. We'll talk about some advanced kind of features and other things, but there's a lot of documentation in the IBM development site and the administrative documentation. From the default, TWS provides a basic security.config template that you can build from. With LDAP and single sign-on, it enables us to apply filtering and restrict access to AD security groups. So in the example in the slide, we have the security group in TWS-operators restricted to specific roles. So they're able to access and jobs in a specific way and schedules and resources, files, specific workstations. You can become very granular with how you want to restrict access. You can combine kind of syntax, so we could restrict a workstation and specific jobs that maybe have some prefix in their naming convention to either be read-only or allow users in specific security groups to be able to cancel jobs, rerun jobs, submit jobs. So kind of making the TWS security file your friend is quite important, and I definitely recommend going to the administrative guide and looking at all the options. The two commands to edit and then apply those changes are the dumpsec and makesec commands. Dumpsec, basically, you just export your security file into a text file, you make the changes that are necessary, and then you apply those changes with the makesec command. In the dynamic workload console, we can also provide kind of view access. So in addition to the particular objects that we're restricting to the GBS security file, we can also restrict who has access to what views in the dynamic workload console. And this is done through this group roles panel. What's nice about single sign-on and LDAP integration is we can utilize the same groups that we specified in the GBS security file into the dynamic workload console. So it kind of provides a very seamless interface. The users have specific access to views in the dynamic workload console, and those views associate with specific access that you've provided to objects in the GBS security file. Again, there's specific information on these roles and the administrative guides worth looking at. Some of the high-level one administrator kind of gives access to everything in your environment, and then different operations and development and configuration roles and reporting roles as well. So that's quite granular as well. Okay. Another area we can restrict to LDAP groups is in the broker security properties file, and this is all managed through the show broker security properties script and the change broker security properties script. Similar kind of process as the security file. We export to a text file and we import by running this script. It's not as maybe widely used as more people try to get into kind of dynamic scheduling, but this is another way that we can seamlessly kind of integrate LDAP into our environment and make security a little bit tighter, and also bring down those the administrative overhead. Okay. So there's just a few it's kind of more advanced GBS security file role boundaries that we can have in this example here. So the security file rules enable us to exclude and include users. So we, depending on the syntax that's provided, you can be very granular what roles you want people to have, what roles you don't want to have to really secure and tighten up access in your environment. Something to be aware of is that a submit access gives people the ability to run ad hoc jobs. This kind of provides somewhat of a security risk. If somebody has access, they can kind of run any ad hoc jobs they'd like. So it definitely opens up some potential risks, especially for inexperienced users. They could, accidentally or explicitly run jobs that maybe aren't appropriate for them to run. So we can restrict jobs and commands and scripts to also specific directories as well, and even specify the commands that a user is able to execute. So we have a lot of flexibility when it comes to security. It makes sense that we're starting kind of at a high level, and then kind of we're granularly working our way down to tighten up our environment. But just to be aware that what's provided in the scheduling environment, what we can do to really lock down access if it's appropriate. A lot of this is going to be kind of personnel related, working with different groups to find out what they really need access to. But the kind of technical aspect of it is certainly available to all administrators. Right. And hand it over to John Ellery again.
Okay, very good. Thank you, John. So we've got, now we're going to talk about some more specifics about securing the actual agents in your environment. And if you look at a FDA versus a dynamic agent, there's different configuration files for those. Right? The local ops file is used for the fault bound agents, and there's a local option called JM no root, and you can set that to yes, and it prevents any FTAs from running root jobs. Otherwise, it is possible to run root jobs. Now, as John just pointed out, you can qualify in your security file that only certain users can run jobs as root. So you could leave this as allowing root, but lock down the security file who can submit jobs that run as root. So you've got different levels of control. But if you have a certain server that you say no root jobs allowed, you can lock it down through the local options file. And as far as the dynamic agents are concerned, there's the jobmanager.ini file. There's an option there that says allow root equals false. And that's the default actually in new installations. So by default, you're not allowed to run root jobs. If you need to, you have to enable it on the dynamic agent. So be aware those two configurations exist to prevent root access. You've also got different configurations that you can look at for SSL. The configuration for SSL for FTAs is in the local ops file, and in the dynamic agents, it's the ITA.ini file. And again, going back to security risks, the older your environment is, the more likely that any potential risks have been already exposed in terms of libraries, security libraries and things. So the more up to date you are, the less likely you're going to have a an issue with your environment. So try to keep your patches applied as much as possible. One other thing about agents, in the security file, there's a list keyword that allows you to list out objects, jobs, job streams, resources, prompts, all the different objects that are in the plan or the database. By default, the EN list security check global option is set to no in new environments, and that's a legacy behavior. Basically, it used to be the list keyword was not there and wasn't enforced. But now, if you want to be able to create dashboards or things that only show certain jobs, or create lists of jobs that people can see in their tasks, you want to lock it down to just what their application team is allowed to see, you have to set the list security check to yes, and then the list keyword in the security file will be honored. If it's set to no, it doesn't really honor the list keyword. Let's just be aware that's the case. Okay, next slide. So protecting against physical intrusions, you can potentially put another master in to control agents. Somebody could try to take over your agents. Basically, you've got many ad hoc commands from the FTA or any other agent to your automation network. So if you have access to an FTA and you have root access to that box or access to the FTA user, the default security file gives the root and the TWS user access to do anything on that agent, including submitting jobs to other agents. Okay? So you may want to consider updating the security file in your FTAs to not allow access to others. Or actually, I'm sorry, use centralized security in that case, because even if you lock down the security file, if you have root access, you can unlock unlock security file by changing it. But if you use centralized security for FTAs, then only the master security file is acceptable on the FTA, so nobody can change it locally and give yourself more access. So if somebody happens to get control of an FTA and root access to the FTA, they can't use that as a vector to get into other agents in your environment. So centralized security will prevent that from happening. All right, and you can use the resource CLI from the DA to access broker resources. So that's another area where you may want to look at locking down to make sure that from an agent or remote agent, you can't have more control over the network than just the local agent control. All right, so if you want to really lock things down, you can enable SSL, right, with your own keys between all components in your environment. And that way, it's a really secure connection. Again, it's not necessarily required in a corporate network because you've got lots of other layers of security already protecting you. And if you're going outside of your corporate network, then it might be something more to look at. John mentioned the broker security properties, so there's a way to control access to the broker with security properties. And secure passwords, and limiting who has access to the credentials for the administrator for TWS. And then another option is IP validation. There's a setting in the local options file that allows you to basically have TWS check to make sure that the IP address matches. If an IP address comes in, it tries to do a lookup and match the agent in the Symphony file, which makes sure it looks like the valid IP address coming in for that particular server. If it's not a valid one, it won't accept the connection. That's a way to prevent a strange master, an unacceptable master from connecting to an agent because it would reject the connection. All right, and I mentioned before centralized security. That's the case where I've got an FTA, I've got a security file in the FTA that only allows the TWS user in root to actually get access, but somebody gets access to root on that server, right, through some other attack that they've performed. At that point, they could change the security file in TWS to give themselves more access, or that FTA may have the default security file, which gives them access, full access. And so they could submit a command to run on any other server that's part of the network at that point, on the master and any other agent. So using centralized security, you've prevented that from happening because they cannot change the security file locally. So even with root access to one agent, you can't go outside of that agent. And just in terms of configuring that, you've got to generate the security file on the master. You'd have to distribute the security file out to each of your agents, and you have to make sure the global option enables centralized security is set to yes. That only applies to FTAs. It's not really related to dynamic agents at all, since basically the control of what gets submitted and run is from the master, from the broker in the dynamic agent case. FTA is more decentralized. So the last thing we want to talk about as far as the hacking side of things would be, how do we know who did what and when in your environment? And if we look at the various auditing features in TWS, you can do client auditing and you can do database auditing. And in terms of the database, audit records are stored in the actual TWS database. So if you change a job, add a job, delete a job, modify a job, that's recorded in the database, as well as it can be recorded in files on the master's files. Client activity is only recorded in files. So if you want to see who canceled a job or ran a job, you go to the audit files and check, look for a record that matches the object you're interested in. And it would have information about who did it, what time they did it, and what action they performed. So it'll say cancel job A at 10 o'clock, and it was canceled by this specific user. And it is traced to the individual user, whether it's LDAP or whatever authentication mechanism you're using. You'll see the individual user ID in the audit records. With the database activity, again, it's recorded in a file and in the database. And I don't know if anybody's currently using the batch reporting CLI, but if you're not using it, you should take a look at that. There's a lot of nice reporting capabilities in there. And one set of reports that you'd be interested in is the audit report. There's an audit detail and an audit general report that can show you when somebody changed the database object, what they did to the object. With the detail report, it actually shows you the before and the after object definition, so you can see what changes were actually made to that object. And that can be distributed through email to auditors or just administrators to see what activity is going on in the database. I've got a customer that actually sets that up so that it emails it to their SharePoint. They've got a SharePoint email address set up and automatically loads into an audit directory in SharePoint, so the auditors can look at it anytime they want to. So it's a nice way to kind of track what's going on in the environment. So the other thing we want to be able to look at is what users are logging into the DWC, and there's actually a tech note there I've included that provides information on how to do that, how to enable logging of users into the DWC. So you get login activity as well as on the back end, the client and database activity that was performed through those sessions to tie it all together. And that is, I believe, the last slide. So as far as the summary is concerned, again, I think we're talking about features in IBM Workload Scheduler that help you lock down your environment if it's necessary. But you may not necessarily require any of these features, or you may have learned some new features you want to take advantage of. But it really depends on what's your workload automation network topology. You have all of your agents and your master in a corporate network, secure corporate network, or do you have possibly agents in the cloud, agents on vendor sites, client sites, and all those things are factors to consider when you're thinking about your network design, your security design for your environment. And the other thing you want to consider, and this ties back into the authentication and authorization, is your workload automation stakeholders. So, sorry, I'm going to go off the network again. So the John mentioned different roles, administrator role, operator role, scheduler role. And one of the biggest things I think in terms of security design for workload automation is actually sitting down and thinking about who all the different stakeholders are that need to access the environment and what access they should have. Usually there's a lot of debate and discussion on that. And the actual implementation of the security file, while there's a lot of granularity and control, once you get used to setting up a security file, it's not that bad to understand how to configure it to enforce those roles. But the big thing, usually from an organizational perspective, is figuring out who needs access, what access they need, and then crafting a security file to lock the boundaries of those roles down. So it really, security is something you want to consider very seriously when you're setting up your network. I've seen many different situations where every user has full access. Basically, an end customer set up an engine definition that has the credentials for the administrative user, and everybody logs in BDBC and use that same shared engine. Very weak passwords is a common issue. So the more you think about the security and put the protections in place, the less likely you're going to have an issue with somebody either intentionally or more commonly inadvertently causing an issue in the environment. All right, so last section here. We can encrypt communication, very granular security model to control who has access to what. You can go to user repositories for group and user accounts, which provides a way to actually minimize your administration role. That's a big factor here, is that you set up your security once to define your roles and boundaries of those roles, and then from that point, it's the account management team's responsibility to give access or take access away to TWS. You don't have to worry about that as an administrator. And you can use centralized security, IP validation, broker properties, and root user restrictions to protect your agents. Make sure that nobody's going to actually go onto your agents and get wider access to your system than you should have. And then the audit side, you've given yourself the ability to track who did what when, so you can see if there's any strange activity and follow up on that, and see if there's any tweaks you need to perform on your security design. So I think that pretty well covers the last slide here.
All right. Well, we can open it up for questions and answers right now. And just to recap for anyone that didn't catch at the beginning, if you would like to ask a question, please do so using the chat window located in the lower right-hand corner of your screen. We did have a good amount of questions come in during the presentation. One of the first ones, there was a recommendation to use SSL, but there was a tech note that someone found that said the SSL is disabled, and they're asking what to do with that. They've already run into this problem while trying to upgrade from 8.6 to 9.3.
I think that tech is referring to using a 9.3 dynamic workload console with an 8.6 environment. I'm not sure if that's the case, but I know that there was an issue with older versions of SSL not being supported with Websphere, with the Websphere 9.3, or Websphere used with 9.3. and you have to basically.
Yeah, there's some steps that I think disable SSL version maybe 2 and 3 to get that communication working between 8.6 and 9.3.
Right, that's right. Yep. And that's probably what that's referring to. I guess I don't know if we can get more detail on the question, but that's most likely the tech note. And the DWC will use SSL by default, but in this case, it's trying to use communicate with 8.6 is using an older version, and it's not enabled in the 9.3 version.
Yeah, I think it after you disable it, it goes to TLS. I don't know if 1.1 or 1.2 or whatever version.
Okay. All right, this is kind of a long one, so bear with me. Do you recommend replacing the root certificate as well? We are working on that now, or because the client certificates are all unique, is it okay to leave it? Also, if we create our own root key and leave in Qdo generation of the client keys, do users still have to re-import the new certs every year?
So I guess in terms of root certificate, the DWC, I think you have to import the root certificate with the question. Because it's a little bit different with the DWC versus the TWS. With the DWC, the root certificate is used to automatically generate new keys every year. So when you connect with your browser, and actually I can kind of show that real quickly. If I go to environment here, actually I've already supported the key, but basically the key would show up here, and I can actually see the key that's being presented is going to expire once a year, but the root key is expiring in 2030, 2032, whatever it is, and the DWC will automatically regenerate the key off that root key every year, about 30 days before. And as far as the TWS keys, the key expiration is I think 2029 for all the keys, if they never expire. Self-signed keys until they don't expire until 2029. I guess I'm not sure I answered the question though fully. Basically, you're going to replace in the trust store and the key store your generated keys, your locally generated keys, or if you purchase them from a third party, either VeriSign or Entrust or whatever, you're going to update all the stores to include your keys. That would be the root key too, I would guess, in the United States.
Okay. How does TWS react to SSL Certificate Expiration?
Well, depends on the component, right? Because if the client key expires, you're not going to be able to access the command line, or single sign-on will stop working, I guess, if your key expired between TWS and DWC. From a browser perspective, if you're accessing DWC, you're going to basically get a warning, and you can usually override that warning or error from your browser. So that key is usually easier to manage expiration of. But I guess browsers don't, once it expires, it doesn't accept it at all. It's not a correct key to accept of an expiration. Basically, you're not going to be able to operate your environment if your keys expire. You have to make sure they're updated.
I'm sure a lot of people have to deal with that with 8.6 and applying 6.3. Not that long ago, last year.
That's right. Basically, all the components are separate. 8.6 is a good example, right? You had to update the keys, they all expired.
Okay. Can you recap the way that TWS security is centralized so that FTA access and control is limited by the master?
Sure. So in that case, you go to the global options file, you set centralized security to yes. you have to wait for one cycle of one plan extend to occur, or you can refresh the plan with your JNX plan 4000 to refresh it. But once that happens, then centralized security is enabled. At that point, an FTA will only use a security file that's been basically signed by the master. So you have to have taken the security file you built on the master and pushed it out to each of the FTAs and replace the local security file that's already there. And there's no automated way to do that. You have to basically copy it out to each of your FTAs, and then your agent will start to use that centralized security file. And basically what's happening is it's checking the security file against information in the Symphony file inside the plan file to make sure that they're consistent and it's a valid security file. If somebody attempts to remove that security file and create one locally and put it in place, the FTA will no longer work. You won't be able to do anything from the FTA. So it has to come from, have been generated by the master and then distributed out to the FTA.
Awesome. Where do we configure IP validation on the agents, and is that a feature only available on version 9.0 and up?
No, that feature's been around for quite a while. It's back as far as I can remember, it's been a feature. And it's in the local options file on the FTAs and the master. It doesn't apply to dynamic agents. It's only fault tolerant agents, the master, backup master, domain managers. There are a couple of things to be aware of. I've had some issues with clusters where you connect, especially like a service card, I think, where you connect with one host name or IP address and it responds back with a local node name, the local host IP address on the response, and it fails IP validation because it does a lookup of the host name. It comes back with the IP address it tried to connect with, not the one it's responding with. So there are some things you got to be aware of when you try that. So I wouldn't globally try to do that until I test it out with my specific configuration, because it basically is doing a lookup to see if the IP address is correct in the Symphony file. What the master thinks the IP address should be versus what the connection IP address is. It's all done through local ops enabling.
Excellent. Do you have any examples of root restriction by user in the security file?
Yeah, let's go back to the slide. Okay, so this line right here, where it says excluding users, job, CPU equals at. The tilde symbol is the indication that we're excluding logons that equal whatever's after the equal sign. So we could put root, comma, administrator, comma, whatever other users we want. Basically, the tilde and then the keyword logon restricts access to whatever IDs are listed afterwards. The plus in this case says we're only allowing users that in jobs that are specified as DB2 inst1 and IBM CPQ. So these are the only two users allowed, and this one says root is restricted.
Great. When we log into DWC, we see a certificate warning. Is there a way to stop this login warning?
Yeah, and I was going to show that the demo, but I've already actually updated that in my session here. But basically, when you
the self-assigned certificate warning.
Yeah, self-assigned certificate warning. So when you get that error, there'll be, especially with IE, and it varies by browser, whether it's Chrome or IE or Firefox, but there'll be a warning here in the IE case that'll say certificate error. You can double click on that, it'll bring up an indication of the, right? Like this will bring up view certificates. You click on view certificates, you can see that this one is going to expire at 6/1/2016, which will automatically generate again, because I'm using the default certificates, it'll automatically generate about 30 days before and give you an updated key. But if I want to get rid of the browser warning, I can go to the certification path and select this top row here. and then that's actually the root certificate, and I can go to look at that one. That one's going to expire until 2030. Right? And I've already installed it here, but I could install this certificate from this panel, and it puts it into, well, it doesn't put it anywhere. You have to tell where to put it, but you put it into the root trust store, and once it's added to the root trust store, then that root certificate is trusted by this browser, and you're able to bring up your browser every time that warning will be gone. All right. So older versions, IE was not as tolerant. If you were 8.6 or below, I believe there was 2 issues with the certificate. One was the server name didn't match, and the other was self-signed, I believe. But in later versions of like 9.1 and above, I believe that's not the case any longer, and IE is more tolerant or accepting the certificate. You can't always install it through this, though. Sometimes you have to go to your administrator. If you can't update your trust store locally, which some organizations have been, you can't. You have to go to your administrators for Windows and have them add it to the trust store for each of your masters, each DBDC, have that root certificate. And if you do that, even with the default deliver certificates, you won't get the warnings anymore until obviously 2030.
Excellent. Does TWS provide a warning before a client SSL certificate expires?
I don't believe so. Hopefully there's a way. I know with the server certificates in Websphere, there is a way to configure Websphere to send a notification out. But I don't know that that's the case for the client keys, client SSL certificate. But I know the DBC, I believe there is a way to configure Websphere. It's not really a TWS configuration, it's a Websphere configuration. I think you can specify email address to notify when expiration is coming up. I'm not positive of that. I think I remember seeing the configuration Websphere for that. In general, no.
If you switch Centralized Security on, you mentioned that you need to distribute the file to all the agents in the network. If this file isn't distributed 100% success and correct, you have an issue. How do you recommend distributing the security file when potentially it's changing regularly?
Yeah, that could be a bit of an issue, I guess, if you don't have a mechanism in place to push the file. I mean, you could set up jobs in TWS to FTP it out. I think you've got the FTP plugin now available with later versions of TWS, so you could push the file out using the FTP plugin. Just set up a workstation class even, and potentially set up a job and just push it out on a daily basis. So you could use variables inside for the paths and schedule a workstation class job stream and just push it out once a day or something.
Okay.
If you don't do it, you're going to have a problem. You won't be able to even start the agent. So you got to make sure you get the security file out there.
All right. And kind of from the same vein here, if you're not using Centralized Security and you have admin access to any agent in the network, can you confirm that you basically have full permission to the plan and thus full admin access to the entire TWS network?
Yeah, if I'm on an FTA and I have root access to a server, if you look at the security file, the default security file on an FTA gives you full access to the plan. And you can't do everything. Like you couldn't submit a job stream that's predefined. You couldn't submit a job that's predefined because you don't have a connection to the database necessarily unless you had information to configure that connection. But from the local plan, I could cancel a job on another server. I could submit a ad hoc job to run any command I want on any server directly without having it predefined in the database. So yeah, if you have admin access to an FTA, you basically can access other agents, other FTA agents. Now, that's only with FTAs, not dynamic agents. So if you're running with dynamic agents, you don't have that same situation. And centralized security is the way to prevent that from happening because even with the admin access to a box, you can't change anything from the security perspective. It's amazing.
Great. Well, we've pretty much run out of questions and also hit the end of the hour, basically. So John and Jonathan, I want to thank you both for your time and presentation. I think it was a great presentation.
Thank you.
Thank you.
Absolutely. And thank you, ladies and gentlemen, for attending. As you exit the webcast, please do take a few moments to fill out your post-event survey and help us improve our future events. We truly appreciate the feedback. But this concludes today's conference, so have a fantastic day.